Hello everyone, welcome to another special tutorial from Abba Joseph. In this one, we are going to do something really special. We are going to learn how to use different testing strategies to help you test your code better. Now, each of these strategies are not necessarily new, but I just want to show you how I combine them to test really difficult code. So what we are going to be working on is this downloader application that I have on my desktop, which basically helps you download something from the internet. You give it a URL and a folder, and it downloads the file to that folder. So here I have a folder, and then this here I'm going to run the program. This is the program, but first I can go up and just run the program as it is by pressing the enter key, and as you can see, it prints out a message saying I should use it as downloader URL and then the directory. This time around, I'm going to put the URL and the directory, and then I press, and let's wait for it a minute, and now we have the file. Great. Now, how do you test something like this? What we have just, this thing that we just did, is another form of testing. We just tested how the program works. But imagine if you have a lot of complicated arguments to pass to the program. You really don't want to be coming to the terminal and doing it manually. You want to automate that flow. So this combined with unit testing, this is going to give us like a solid suite of tests that we can have for this program. So this, I don't expect the video to be too long, so you can stick around and just see how things go. All right. Please, a quick call for support. If you have not subscribed to my channel, kindly support the channel by subscribing. I think over 93% of my viewers, those who really enjoyed my videos, are not subscribed, so please support me if you don't mind. Thank you. All right, let's go to our IDE and start coding this program from scratch. Okay, now in my IDE, I have just basic stuff. This is the Go module. You can do that by doing Go mod init, and then you put this your URL. This should be your own URL, not mine. So this already exists. And here we have a main, and then main underscore test. No code, nothing. So I'm just going to close this down now, and let's start with main. The first question is, what exactly do we want to do? So I like to work backward. If you look at the program when we executed it, you see we are able to pass command line arguments to the program. That is the first thing that we want to do. 3 command line arguments. The program itself is 1. The second is a URL, and the third is the directory. So, but we are interested in the 2, which is the URL and the directory. Let's work on that first. First, I want to do some checks, which is if len, if this is less than 3, we want to exit, because we definitely want them to. And when we exit, what do we want to print? This is the message that we want to print. We put the message there. Right, good. So far, so good. The next thing is, let's get the URL from os.arms. This is going to come in the second index, and the directory is going to come in the third index, which basically is number 2. All right. Now, what do we want to do next? Well, I'm not sure, but let's do downloader. I like to work backward. Let's say we are going to have a HTTP downloader, something like this. Let's make it a pointer. And then I plan to have a function called download file, something like that. Let's pass it the downloader. Let's pass it the URL and the directory. And we check for error. If error is not me, we can exit like this. But this time around, I want to put message like failed to download file. I'll fix the error shortly. And we can just put error.error here. This should be printf. Looks good to me. So let's start eliminating the errors one after the other. First, I'd like to create this one. Type struct. So that error is gone. Second one is this function. Takes HTTP downloader. So HTTP downloader. It's a pointer. We know the URL and the directory. Both are strings, and the function returns an error. At this moment, we can return nil to just see. Everything looks good. So we check for the argument, extracted some variables, construct our downloader object, pass it to a download file function, and then we created the type here and the function here. How do we intend to implement this one? I want to keep this one simple by maybe we should go here and call it download method, passing it the URL and the directory, something like this. Can create the method now. Okay. Right now we can let's implement it right away. But if we go ahead and let's say I return nil, I run the code, go run, we are going to get the first message, this one. And if I pass, let's say test, so this is like the URL, let's say URL and directory, there will be no message. Great. So it's working, but we can also make it more interesting by saying file downloaded, something like this here. Okay, we are doing good so far. So how do we implement this? This is not hard. Response error HTTP. So I'm not going to do anything fancy like creating a client, handling redirect and all this thing now. We're just going to keep it simple. We check for error. This classic Go coding pattern. Defer the closing of the body. Okay, after this, what next? So now we sort of have the file. We need to construct the file name, which is file name equal to path.base. Response always have object in request object embedded. We can take the last part of the URL as the file name. Now this one is a little bit tricky because if you have a redirect or some kind of dynamic output that doesn't have file extension, the download would look a little bit weird. So I think the best way to deal with this is really looking at the content type and doing something with it. But yeah, this would work for now. File path, join. I want to join the URL, the directory and the file name. Okay. In my videos, no magic. I keep everything raw. I think it's important because when people are learning, they should at least see some mistakes. Things are never perfect like that in real world. At work, we struggle, we do research, we look up things, and that's how people work. Now we have created a file. Basically, we just need to copy the body that we downloaded into this file. That's it. And I'm going to, of course, defer the closing of the file. And I'll use IO copy. This is the number of bytes read. Error is equal to io.copy. Destination will be the file, and response.body is the source. You can click on it to see byte written, and this. So I'm not interested in that. If you are interested in limiting the number of bytes you want to copy, you can use copy n. I've used it a lot of time, and you give it like, say, this is the number of bytes I want to copy. It's a very useful function. At this moment, we can return the error. Something is not right here. Oh, yes, 5 paths. And I wanted to name it 5 path. Fantastic. All right, time to test it again. Here, there should be an error at least saying the URL is not valid. Great. Want to copy what we put here initially. Let me create the downloads folder here. Great. Let's run it. Nope. Go run the main, and great. No errors, and we have the file downloaded. Beautiful, beautiful. We're working. Now time to test. The question is this: what do you test? I want to test everything, but where do I start? Of course, this place is a little bit too much and tricky to test, so I won't start there. Let me start with this one. We already have the test main, so I'm going to just say func test. Let's rename this to, it's not HTTP downloader, it's download file we want to test. Okay, how does it work? It's a very simple function that takes this one. All right, so let's do it. HTTP downloader, HTTP downloader, and error is going to be equal to this one, about the HTTP downloader. Let's give it that same URL that we gave it. I can give it downloads again. Great. But before I do that, I want to delete this, and then I show you what the problem is with this approach. Don't worry, if you've seen something I don't like, no problem, we'll fix it soon. If error is not near, that means we have a problem. Error should be near. We say error F, expected error to be near, got, and then I put what we got. And I'm just going to go ahead and run it. And it passed. Great. But the problem, what is the problem with this? It passed, but it went to the internet, and I don't want it to go to the internet, because then when there is no internet, you can't run this test. And if you look at our program here, the problem, this is problem number one, is that this is our code. This is our sort of user land code. You can imagine this as an external library. We are now, this function, download function now depends on this. So this is our dependency. And we need to come up with a way to work with this dependency without going to the internet. This is really important. So strategy number one is using an interface. When you use an interface, you are able to mock things. So let us refactor to use an interface. I'm going to come here. Let's take this code, and I'm going to say type downloader interface, and I put this here. Let's free up. If we're going to free this now, I'm just going to change it to D and D dot this. As you can see, everything still look great. When we come to the test, let me come back to the test and run the test again. We see we've not broken anything. The program still works, but the problem is still there. The program is still going to the internet. So in order to stop that, let's create a fake version of this, but satisfy the interface. The great thing about interfaces are they are contracts. As long as you do what they ask you to do, everything would be fine. So I'll go and I'll say mock HTTP downloader, or you can say mock downloader, or whatever it is. And what I'm going to do, I will come here. Where is this one? I'm going to copy this method out. Short, we can just copy it like this. This is our mock. I put it right in the test. Change it to this one. And I'm going to return me to show that it's successful. Then I'll swap out this with this. We are going to run the test again. This time around, I'm going to actually delete the folder completely. We run the test and the test now passes. No problems. But I also like to run it with coverage so we see what we have covered and what we've not covered. It's passing. Let's go to main to see what we've covered so far in main. If you look at this, look like 100% covered. But I also want to check sometime when there is an error. I also want to test for that, even though it looks like we've covered everything. So I'm quickly going to duplicate this and I would say error. Now, in my professional work where we write production level program, we're going to convert this to table driven test. Well, when you are teaching something from scratch like this, you don't want to complicate things too much. So I'm going to keep it simple by duplicating the code like this. But here, I want to signal an error. That means because this is our mock and we have a lot of controls, I'm going to say is error or something has error. Let's say has error equal to boolean. All right. If error 0, we return. Okay. We come down here, set it. This moment we say if error is near. Okay. This is now going to change the test coverage number, but it's fine. Great. Still remain the same, but we're doing good. All right. Now, what do we do next? We want to test this part of the code. I mentioned previously that when you are looking at your code, always think in terms of dependencies. So like, what are my dependencies here? Here, we depend on this HTTP library, especially the get method of it. We are depending on it. So how do we replace this? Now, strategy number one, which we used an interface and we provided a fake implementation, what that we just did, you can use that here as well. Maybe you can inject the HTTP client or something. But we want to learn something else. We want to learn strategy number two because this can be a little bit more. Imagine you are talking to like an ERP system or a CRM system that mocking it is going to be tricky, or you want to have different response. You want to check for different kinds of responses from the external system. The second strategy that we are going to use is to replace the server. So instead of going to the real server, we provided a fake server and then we can mock the responses. All right. So, but before I do that, let me do a quick refactor. HTTP downloader. We can go to main. Let's take out everything from here. Bring it in here. Okay, that looks, main is looking better, I think. Yes. That means we can now come here, HTTP downloader underscore test dot go, and this is what we are going to test. The first thing I want to check is Maybe we should start with the success case, right? Let's try to download something. Function test HTTP download, something like this. What do we need? We need a directory, so I'm going to say temp dar error os.create temp. If you are using an old version of Go, I think this was in the different package, create temp. So, but you should be using the latest version of Go. When the folder, we need a temporary directory. Error is not me. I'm going to say tfeta because if we are unable to create a temp directory, there is no need to continue with the test. That means our test is going to fail anyway. And I will say os.remove all so we can delete the temp dar. What are we getting wrong here? I need the name. All right, looks good so far. What else do we remember? I said we are going to replace the server. So when http.get is called, instead of going to the internet, it's going to hit our mock server. Let's create that server now. Test server, and this is the beauty of Go. You have everything built in. We don't even need any external libraries to do this, right? New server, and what do we need? We need a HTTP handler func. I provide a function in like this. Function argument is, let me go back, sorry, let me backtrack so that I can take advantage of the autocomplete here. Great, instead of typing it. So this is the server when what we want to, this is the file we want to send. You can just send any bytes, number of bytes you like, just test content here, file. So this is now the server that we are going to give to the download function. Don't forget to, anytime you are doing IO operation, always remember to define the closing. If you are in a loop, you have to close it in the loop. But here, we defer the closing of the server and then the URL. This is the fun part. The URL will now equal to test server.url. Okay. Now let's make instance of our HTTP downloader. This is the real one. Remember, before we couldn't do it like this because it was going to the internet, but we have just replaced the server now by doing this error download. URL will be our URL and tempdar.name. You see the beauty of what we are doing here. We can say rf from, I'm going to say http downloader dot. I always like to do something like this, error is equal to error, something like this. Now time to run the code. Let's run it. It passed. Let's run the coverage to see where all the coverage that we have in that file. You see 83% covered. Okay, so let's see what we've not covered. Here, we've not covered this part. We've also not covered this part, which is not very hard at all. Basically, I'm going to duplicate this. I'm going to duplicate this one. And I can say URL error, something like this. For that, in order for us to cover this part, we want to attempt, want to force http.get to fail. So let's give it an invalid URL or something. We don't need the temp for that. We also don't need the servers for that as well. I think by just giving it an invalid URL, that should force it to fail. Something like this. So if error is here, I made a mistake here. I'm going to bring this back. If error is nil, we just say expected an error got nil, something like this. Oh, we take this one out and we don't need error F. Okay, let's run it and see. Great. Now let's run the coverage. You can run the coverage from the terminal as well using dash cover. We're at 91%. Great, we are doing good. Let's check more. Everything, we've covered everything here except this part. So when, and this one is very simple. This one, we are going to need almost everything here. So we just need the path to be invalid. So invalid. In order for the path to be invalid, I think I'm going to take all these ones out and just give it invalid. Okay, and we'll do this. If error is nil, we expect, actually, we can just take this message here. Expected an error here. If you can test for the specific error, but that is not, got an error. Yes, sorry. If error is equal to nil, if error is equal to nil, expected an error got nil. Is that what we're supposed to write? Let's run it. Let me check one more time. Expected an error got nil. Let me take out this one. Let's run it one more time. Okay, great. So that would force the directory to fail since it's an empty string. So let's run the full coverage for that now. Then we do a recap. Fantastic, 100% covered. So what have we done here? We started by, let's start with the code. Looking at our code, the download method, we know that we depend on the HTTP library and the get method. We know this is our dependency. And of course, here we have a few options. One is to inject a HTTP client and then create maybe an interface or do a mock, and that's something that we've seen already. But instead, we went for the option of replacing the server and by providing a different server instead of it going to the internet, which we did by leveraging the test HTTP server that we have here in the Go library. And of course, we made use of creating temporary directories, deleting them after the test, and creating a mock server and providing the URL instead. Now, if you want to test like different server responses, HTTP method, or different status code and all that, you can make this into a table-driven test and run everything. But as it is, we are good. Now, if you go back to our main, there are still some stuff said that we can test, but usually most people stop at this. And this is where we want to take it up a little bit. Now, what I want to do next, I want to extract what we have here into a different function, and then we can test it. Let me start by creating a function here called run. Let me move everything that we have here and bring it in here. Okay. Let's start replacing stuffs. First is this message we are printing out. I want the message to go somewhere. I'm going to take out io.writer. The beauty of Go is with io writer and reader, you can do magic. All right, so args, this would be string. Okay, here we are going to keep the same thing, but this here we are going to let's change it to fprint ln or something like this. And the out becomes what we are printing this message to. Here we should return nil or something. Error. We have a lot of options here. I'm showing you, you can, of course, we can return the error, go to main and check it and all that. But there's a reason why I'm doing this. So please stick with me. Then very similar approach here. We are going to also replace this and change it to this. Okay, and that changed to, since we know that this one also produces an error, maybe we just return the error itself. Okay, and at this point we can just bring this one here. Okay, nothing much, then return nil. If you look at it, just only the error we have here, it's possible for us to not return anything, an error at all, and just put everything here, but I'm just going to keep it this way. And the next thing we want to do is to bring the function here. Let me delete everything here, and I can also delete here. I'm going to change this one to run. We are going to out, it will be, let's set it to std out os.args. We can do here, I want to change it now to fprintf os.std error, just to fail to download file. What else? I think that's it. Yeah. Now that we've moved out some part of the code, we need to write test for this one. So let's learn how to write test for this. Come here, we are still in main, so I'm just going to say func test run. T, take a pointer to D. Great. Out, where do we want to print the strings to what we are printing from there? And this is what I want you to learn. We can create a buffer, bytes dot buffer. Okay. We go the same approach. Let's take this let's take this temp stuff from here. We also need this one. We need, yes, I think, yeah, let's just take this path, come here now. Okay, I'm going to say error is equal to run. This is what we are testing. Out, let's pass it slice of string. This is going to be the downloader, the test server.url, this one. Remember, this is what is passed on the command line. When we executed the file, this is what we are passing. The same thing we are constructing here in code. Then temp_dar.name. Right. If error is not nil, we're going to just hit error here. Let's run it. Okay, What is unsupported protocol scheme? All right, let's see where we are. What is failing? Let me try to run it one more time and see. Get test.v unsupported protocol scheme, empty quote. There's for sure something we're not doing right here. Let me check inside the code itself. This here, HTTP downloader. Okay, I've seen the error. In case you haven't seen it, here, sorry, here, here. Okay, let's go back, run it again. Great, it passed, but we also need to run the coverage. Replace it. Look at main, we've covered 57% of it. So as we've covered everything here, we covered this part. So we need to cover for the argument, which is very easy to do. For that, I won't even need to have much. So I just duplicate this, delete most of it. I'm going to delete everything. Invalid tags. Just going to make it maybe just one. It's supposed to be three, but we just give it one and it will fail. We need the buffer. Without the buffer, if we don't pass the buffer, we are going to get a panic. The error here, if error is equal to nil, then there's a problem and expected an error. You can check for the specific error you expect, but this is enough to make the video, to make sure the video is not too long. All right, I was trying to avoid panic, but we got it anyway. So let's go back to run. And we also have, and this is why refactoring, and when you have a test and you are refactoring your code, you start catching the errors. Look at what we are checking here. This is what we're supposed to check. So we caught that error right away, and that is what is causing the index out of bound panic there. All right. Expected an error. Is that what we expect? Yes, so let's go back to this. If it's less than 3, oh, we are returning nil here. So good. Let's check for this specific message instead. Good, good. So errors should be nil. If let's make sure the error is nil. But we want to check for the message. If out.string is not equal to, what is the message we had put in there? This one. And this is it. Then we can say t.error, invalid error message. So just like that. Let's run it again. Invalid error message. Maybe there is a sort of new line or something. Great. And that was it. Good. Let's run the coverage one more time. You see how we have used buffer, the buffer to replace printing to the screen, and we are able to inspect the data. We are at 71%. All this part is covered. We need to now cover this part. How do we get this to fail? And I think we can get it to fail by providing it an invalid URL or invalid directory or something like that. So let's do it. Let me come here. We can probably duplicate this. Put it here. I'm just going to say fail download or something like that. Okay, we still need the buffer. We need the temp. We need the temp, I think. Yes, we need the temp. So let me bring the temp. Yes. So here I'm going to put for the URL will be invalid, and then we put the temp name. Okay. And this is where we check that if error is near, we the error expected an error got near. We can remove that here. Let's run it. Great. Time to run the coverage again. All right. So, and we are at 78. But if you look at the run function, we've tested everything. The only part is this, which is nothing. But, most people definitely would stop here. Like 90% of people will stop here. But I know you're probably asking, now, what else can we test? Though we can do everything, how about the program itself? This is our code, is working, but how about the execution of the program? Strategy number 3, we need a way to test that when the users are running the compiled program, they are passing in the correct parameters and the program is behaving accordingly. That is what we are testing next. And this is the last part. This is really, for me, this is the most interesting part. Let me come to this place and type so what we want to do, test executable. Right, so what we want to do, what I'm going to do is going to sound a little, let's delete this, this came from the test. What I'm going to do is going to sound a little bit weird. I'm going to compile the program, I'm going to pass in the arguments and then inspect the output. Simple stuff, right? So let's say compiled command, cmd, exec, I need this one command. We are going to call go build. We are going to send the output to as downloader, right? This is going to help us run program, compiled command dot run. This is going to compile our program. Trust me, most people don't do this. They don't even think about it. Then we need our temp directory again. We're also going to need the test server. So test temp directory. Do we have the test server anywhere here? Sure we do. Bring the test server. Remember we define, all right, we've done this a million times. Next is let's create a buffer just like we did here to hold the output. Look at what we are doing. We compile the program. So we are going to have a re-executable file here, downloader, exactly what we have on the desktop, this one, like this. And then we are going to pass in arguments for it. All right. So we have the buffer. Next, how do we run the program? So let's say the run command, very similar to what we have up there. Exec.command. So we know we are compiling it to this directory, so we'll call it, and then we pass in the test server.url. Then we pass it the temp.dar.name. Now, instead the output, how do we capture the output? You can capture the output by replacing the output, std out. We are going to set it now to out. So all our output is going to the buffer. All right, what next? Let's run it. We did the same thing here. This is what we have here. Let's run it. This will now run the program, pass it all the arguments, and then we see. What do we want to check? I want to check the output because this is a success case. Ideally, we should have where it's run, we expect this to be the output. So I'm going to go here and say if the string does not contain string does the output does string, if it doesn't contain this, then I would say t.error f. Yeah, expected, maybe something like this, got v or something like this, dot string. You probably want to save this into out str. I don't know how expensive it is to turn the bytes to strings, so I don't want to do it twice. Let's run it and see. But something we are missing, we need to do a cleanup. We need to delete this program when we are done. So let me come here and say error os.remove and loader. If we can remove it, we should show an error. That way we don't keep the compiled version around. Let's run it. Maybe it's going to fail. Yes. Exec already started. Let's see what I'm getting wrong. Compiled. It compiled for real. That is correct. Everything looks good here. Command. Then exec command. Let's see what I'm doing. Oh, we are calling the wrong one here. Great. Mistakes happen. Let's run it one more time. Even if it failed, it should be something else, but we passed. So you see, nothing here, it cleaned up. And of course, this is not going to show in this is not going to show here, but the good thing is, let's say we go here, for instance, and we change this message, or for some reason, we no longer print this message. Maybe someone made a silly mistake. We are, of course, so some improvement can be made to this test to ensure that this always, maybe we can do a defer here. Let me come here. After the compile, we do defer func, something like this. Let's run it and see what happens. All right, so it failed, but of course we are able to still clean out the downloader. You see, no more message is printed out, and then we're having an error. So you need to go back and let's restore it, and our test should be passing again. This is the beauty of writing an end-to-end test. You see how we've tested it? We can test one more case. This is the last one. We probably, yeah, I think we should test the case where there is no argument passed, or the number of argument is incomplete. For that, I'm going to say invalid args. We still need to compile it. We don't need the temp directory anymore, since we won't be passing any of this, but we need the buffer. I'm going to command. Let's see what the commands take. So args is just, right, so we can take this out. That means it's going to have just one. This is it. The output we are expecting at this time is this one. Very important. We can go to the test and we say, if it's not this one, we expect it to be this, something like this, but got this. Yeah, let's run it and see. Fantastic. And this is it. If you go back there, for instance, and let's say for some reasons you are no longer printing out this message, then the test is going to fail. Great, it failed. You see how powerful what we've done here today. We've covered very powerful concepts, 3 different strategies. Let me do a quick recap. Let's go. We started with let's go to HTTP downloader. We started by depending on this concrete type. Then let's go to main. We swap it out with an interface. That is strategy number 1. Your ability to swap out a concrete implementation with a mock version. And look at, we have not used any external library. Everything is done within Go. And this is very powerful. Then second strategy is in order to test the HTTP downloader itself, because we depend on the HTTP library that is reaching out to the internet, we created a mock server and replaced the real server, the internet server, with our own mock server, and we are returning the right response. Then the third strategy that we used was for us to compile the program, pass it all the expected arguments, and inspect the output. How are we inspecting the output? We're inspecting the output based on the fact that instead of, at first, we were using printing to the screen directly, like we just print out to the screen. But now we have changed that to print to IO writer, and this open up opportunity for us we can even create our own implementation of IO writer. So we now use the buffer to hold the output, and that's it. Thank you so much for watching this video. If you have enjoyed this tutorial, please consider subscribing to my channel. I have a lot more coming, and I think I create really nice videos. Yeah, self-righteousness. Thank you. Bye for now.